Neuromuscular system adaptations. In terms of the adaptations that will take place both during and after exercise, these adaptations can range from different recruitment of muscle fibers as well as things such as hyperplasia and hypertrophy. In terms of the adaptations that take place after exercise, your body will recruit more fast glycolytic and fog fibers before the exercise begins in order to allow performance to the maximum of a person's ability to occur. These fibers will be recruited as they are most effective in terms of this particular type of exercise, as it is of a high intensity and low duration. These fibers are in what are known as motor units. The brain will control during and before exercise how many and what particular ones of these units and fibers to recruit. One adaptation that occurs in the more you train and perform a certain exercise, for example this anaerobic exercise, would be the more fibers the brain will recruit per time, therefore improving performance as one adaptation due to this. Another neuromuscular adaptation that can take place would be muscular hyperplasia and hypertrophy. These are adaptations that will occur over time as they consist of the increase of a particular muscle tissues or overall size and strength. For example, repeatedly working your biceps for long duration of time would see an increase in muscle size. This principle is applied to any muscle in the body and is therefore a neuromuscular adaptation of exercise. There are more neuromuscular adaptations that take place and reasons why these adaptations take place. These can be found in the next slide, where these will be discussed in terms of graph analysis. Wingate graph neuromuscular section. The graph above shows stages and results from the Wingate test data we collected. In the graph, we can see the duration of a typical Wingate test. For example, as you can see, the graph starts off with a fast increase where the performer reaches their max, which is also known as peak power. After the performer has reached this point, we see a slow and steady decrease until the end of the test. This is expected as at first the performer would reach their peak power and be unable to reach it again and slowly decrease from then on. In terms of the neuromuscular system and anaerobic adaptations, these are neuromuscular adaptations that would increase performance and therefore adjust the way this graph would look. For example, a neuromuscular adaptation that would be beneficial to a performer and change the way this graph looked would be neural pathways becoming refined and ingrained, therefore allowing impulses to travel faster. This adaptation would occur over long-term training and would increase performance as the impulses can be sent faster, and therefore the command word go would see a much quicker reaction time as it takes a person to begin the test. As well as this would mean that a person would contract their muscles faster as well as react quicker to the start, and therefore their peak power would be reached faster, meaning the graph, instead of rising like this, would rise at a more steady increase like that. This would change the way the graph looked to give a more steady increase and would reach peak power faster. Another example of an adaptation that would take place due to long-term training and would change the way this graph would look would be an increase in the recruitment of fast glycolytic muscle fibers, and the more of these fibers recruited due to this training. This would cause the graph to change, as this would allow peak power to sustain and plateau for a short amount of time at the top, as opposed to just decreasing right away. As you can see in the graph above, peak power is here, and with these adaptations that were just mentioned taking place, this would allow peak power, as instead of just decreasing straight away, to plateau at the top here. and you would see peak power held for a couple of seconds. This is due to the fact that there are more of these fibers being used, meaning more power can be generated and therefore sustained for a longer period of time. This would then cause peak power to, instead of decrease right away, level out for a bit and overall increase performance in this test and power. This, in terms of sporting examples, would be similar to a 100-meter sprint. For example, if the adaptations discussed were taking place in a 100-meter sprinter, as they are anaerobic, this would cause a dramatic increase in their performance, as they would be able to sustain their maximum speed for longer, as well as being able to reach this maximum speed quicker. This would mean that they would overall decrease the amount of time it would take to run 100 meters, and therefore cause them to improve dramatically in their sport. In addition, in terms of a games player, this would be relevant to for a footballer. These anaerobic adaptations would be needed in football for a player to reach the ball first, or when sprinting to counter-attack. Therefore, you can see neuromuscular adaptations to anaerobic exercise are relevant to many sports and events of the adaptations that occur due to the repeated anaerobic exercise.